Math 7a, Exam 2, question number 6. Find the vertical asymptotes of the rational function. Write asymptotes as equations of lines. Not just a number, but the equations of lines. Okay, looking for vertical asymptotes. The function is given to be f of x equals x minus 2 over 49x minus x cubed. Vertical asymptotes are going to be the set of x's that are zeros of the denominator after simplifying, right? We only postpone simplifying when we're looking for a domain of a rational function. Otherwise, we have to simplify first, if possible. And indeed, in this one, we will be able to simplify because we can factor the bottom. First, we pull out a common factor x, and then what's left would be 49 minus x squared, difference between two squares, which we factor as x plus 7 plus x times 7 minus x. The 7 minus x's are going to cancel. We get negative 1 over x times x plus 7. That's our simplified version of the rational function. Step 2, find the zeros of the bottom. Set the bottom equal to 0 and solve, and you'll get x equals 7 and x equals x equals 0, x equals negative 7. Step 3, write the vertical asymptotes as the equations of these vertical lines. So the equation of a vertical line is x equals a number. So we have x equals 0. We also have the vertical line x equals negative 7. Let's scroll down to question number 7. Give the equation of a horizontal asymptote, if any, of the function. Write your asymptote as an equation of a line. Okay, so now we're going with the equation of a horizontal line, so it's going to be y equals a number for our final answer. So here's our function. G of x equals a rational function x squared plus 3x minus 5 over x minus 5. Now we have to consider the following. If the degree of the top is greater than the degree of the bottom, there's no horizontal asymptote. On the other hand, if the degree of the top is equal to the degree of the bottom, then there is a horizontal asymptote, and the equation of that asymptote, in other words, that horizontal line, is y equals the lead coefficient of the top divided by the lead coefficient of the bottom. And then finally, if the degree of the top is smaller than the degree of the bottom, then the horizontal asymptote is the x-axis, and that has the equation of the horizontal line y equals 0. Okay, so here we have a degree 2 polynomial. On the bottom we have a degree 1 polynomial. So what we have is a degree of the top is greater than the degree of the bottom, and that means there are no horizontal asymptotes. Moving on to question number 8, comparing h of x equals 3x squared minus 6x minus 8 over 5x squared minus 3x plus 4. The degree of the top is 2, right? That's the highest power on x. Degree of the bottom is also 2. So we have the degree of the top equals the degree of the bottom, and that implies that y, this is the horizontal asymptote, y equals the lead coefficient of the top divided by the lead coefficient of the bottom. The lead coefficient is a number multiplying the highest power of x. So on the top, it's a number 3. On the bottom, it's a number 5. So the final answer for the horizontal asymptote on number 8 is y equals 3 over 5. And finally, we have question number 9 on this page. F of x equals x plus 3 over x squared minus 1. Let's compare the degrees. The degree of the top is 1. The degree of the bottom is 2. So the degree of the top is less than the degree of the bottom, and that implies there is the horizontal asymptote, the x-intercept, which is the equation y equals 0. Okay, we have time on this video to go on to question number 10. Find the indicated intercepts of the graph of the function. Write intercepts as ordered pair x, y. So specifically, they're asking us for the y-intercept. So there's no need for a plural. There's only going to be one y-intercept. If there were more than one y-intercept, we wouldn't have a function. It would fail the vertical line test. But we know here that this is a function, so there will be one y-intercept. F of x equals x squared minus 3 over x squared plus 5x minus 6. We are going to let x equals 0 to find the y-intercept, and we simplify. We'll get y equals negative 3 over negative 6, which is y equals 1/2. Write your answer as an ordered pair 0b, so the y-intercept is the ordered pair 0, 1/2. Number 11, use the remainder theorem to find the remainder when f of x is divided by x minus c. So we have f of x equals x to the 4th plus 8x cubed plus 12x squared, and then we are dividing by x minus c, which is x plus 1. But x plus 1, we see right here, is the same as x minus negative 1. So the c value is negative 1. So we are trying to find the remainder using the remainder theorem. The remainder theorem says that the remainder of f of x divided by x plus 1, or x minus c, which in this case is negative 1, is equal to f of c. In other words, f of negative 1. So go ahead and evaluate f of negative 1 and you get the number 5. That is the remainder of this division problem. Question number 12. Use the factor theorem to determine whether x minus c is a factor of f of x. Say yes or no and show why. F of x equals x cubed plus 4x squared minus 10x plus 12. And the x minus c is x plus 6. So c value is negative 6, and we're going to divide synthetically by that and hope for a 0 remainder. So we're going to divide the coefficients of the polynomial 1, 4, negative 10, 12, divide by the c value, negative 6. Bring down the 1, multiply by negative 6, and then add, we get negative 2, multiply by negative 6. Add, we get 2, multiply by negative 6. Add, we get 0. Hooray, party time! We have a 0 remainder. What does that mean? Then it means the answer is yes. Yes to what? Yes, x plus 6 is indeed a factor of the polynomial. And number 13, list the potential rational zeros of the polynomial function and simplify any fractions. Okay, potential, not necessarily guaranteed, but they're potential rational zeros. Okay, so we have f of x equals negative 2x cubed plus 4x squared minus 2x plus 8. We're using the p over q equals, on the top, the p values are factors of the constant 8. And on the bottom, we have factors of the lead coefficient negative 2. All right, let's list those. We have, for the numerator, factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. On the bottom, those are factors of negative 2, plus or minus 1, plus or minus 2. Now, to avoid writing plus or minus all the time, let's just put 1 plus or minus in the front. Don't miss that. If you don't have that, you've missed half of this problem. Okay, so first we'll take 1 over 1 and then 1 over 2. Okay, so we got 1 over 1 is 1. And then, well, let's do it in a different order because it looks like I did it a little differently here. We're going to go all of the values on top over 1. 1 over 1, 2 over 1, 4 over 1, 8 over 1. Now continue with each of those over the 2. 1 over 2, 2 over 2, 4 over 2, 8 over 2. Simplify and do not repeat yourself. If a number appears, don't write it more than once. So we end up with plus or minus, curly set bracket, 1, 2, 4, 8, and 1/2.